Hi viewers, today's topic is type 1 and type 2 superconductors. So what is the type 1 superconductor? The dependence of magnetization of a superconductor of type 1 as a function of external magnetic field. Okay, the dependence of magnetization of superconductor of type 1. So type 1 superconductor, what it is a function of external magnetic field. Okay. It is obvious from the figure that up to critical field. So what is the critical magnetic field? Critical magnetic field is defined as when a substance is uh, when a superconductor is kept in a magnetic field, and if you decrease or increase, if you increase the magnetic field slowly at a particular magnetic field, this superconductor converted into normal conductor. So this particular magnetic field is called what? Critical magnetic field. It is denoted by Hc. Like this critical magnetic field we define, or we can define in reverse manner also. When normal conductor is converted into superconductor in the when magnetic field is lowered. So at a particular magnetic field, what happens? Normal conductor is converted into superconductor. So this particular field is called critical magnetic field. Okay, so like this friend, it is critical magnetic field. It is obvious from the figure that up to the critical field C, the magnetization of superconductor grows in proportion to the external field. Magnetization means magnetic lines of forces has to pass through it. That is a magnetization. Okay friends, magnetization means slowly magnetic lines of forces has to move through the substance or penetrate through the substance. Okay, suppose it is a superconductor. At the beginning, what happens? At a low magnetic field, lines of forces expelled like this according to Meissner effect. When magnetic field is slowly increased, then this lines of forces starts coming nearer to the substance. When it is again increased, lines of forces starts penetrating through the substance. So that means it is going to magnetizing. As soon as applied field, which field? Magnetic field H exceed Hc. So when Hc value, critical magnetic field is crossed, then magnetization abruptly drop to zero. Okay, so as soon as when a magnetic field exceed Hc, magnetization drop to zero. So that means what it is, its magnetic field becomes what? Suddenly zero. The superconductor, it is a definition. See, the type 1 superconductor is one in which the transition from superconducting state to normal state in the presence of magnetic field occurs sharply at the critical field. Okay, so when it is superconducting state to normal conducting state, then what happens? Slowly, how the magnetic field is increasing, its magnetization also slowly increases. And at a particular magnetic field, this magnetic field, what happens? Suddenly it's a superconducting property suddenly, or magnetization suddenly zero. Then it is simply we can say it is converted into normal state in the presence of external magnetic field. So it is applied magnetic field. So when applied magnetic field is less than the Hc critical magnetic field, magnetic field. So, okay, so in the presence of external magnetic field, Hc is less than Hc is less than Hc. Type 1 superconductor in superconducting state is a perfect diamagnet. Okay, so when H value is lower than the Hc, then what happens? That superconductor is perfect diamagnet. So that means the lines of forces cannot pass through it. When H exceed Hc, superconductor enters the normal state, that is, it loses its diamagnetic property completely. So that means its a diamagnetic property completely zero. So that in diamagnetic property completely zero means it is simply magnetized, means magnetic lines of forces can pass through it. That is the meaning of this. In this state, magnetic flux penetrate throughout the superconductor. So right, so at the beginning when H value is less than the Hc, then it is a Sc superconductor. When H value is more than the greater than the Hc, then lines of forces starts penetrating through it. So that means it cannot act as a superconductor. It is a normal conductor. Why? It is becomes magnetized. Magnetic. It can act as a magnetic material. So critical field value Hc for type 1 superconductor is low. So for it is very small value. Okay. So we apply the H value, very small H value, then what happens? Superconductor simply converted into normal conductor. Examples: aluminum, lead, and indium are the examples of type 1 superconductors. See the figure diagram also. So when external magnetic field is applied in this direction and it is a magnetization, means at the beginning substance it is a Sc superconductor. Slowly what we are doing, we are increasing the applied magnetic field. Then at the beginning lines of forces move away from the magnetic material, this superconducting material. So how the magnetic field is increased, lines of forces coming nearer to the substance again increased, lines of forces slowly start penetrating. So when penetrate, then its Sc property completely converted into normal properties, normal state. So like this it is that this diagram is given. Next, type 2. Type 2 superconductors. The magnetization curve to type 2 superconductor is shown in figure. So this is the type 2 superconductor is characterized by two critical magnetic field Hc1 and Hc2. The description curve is given below. So in type 1 only Hc is there, but here Hc1 and Hc2 two critical magnetic fields are there. Now for the field strength below Hc1, the superconductor expel the magnetic lines of magnetic field from its body completely and behaves as a perfect diamagnet. Okay. So below Hc1 what is this substance specimen can act as a superconductor. Superconductor means it is a perfectly diamagnet. Okay. Hc1, this Hc1 is called lower critical field. The curve is represented by AB. See the diagram. In the diagram, curve is also given. So this is the AB. So from here to here it is AB. Next, as the magnetic field increased from Hc1, so if you increase the value beyond the Hc1, then what happens? See, the magnetic lenses begins to penetrate through the material. So below this, that is a diamagnet or superconductor. Just above it, slowly magnetic lines of forces start penetrating. Okay, slowly penetrate here. Now penetration increases until Hc2 is reached. So that means it is a diamagnet. So how we are applying the H value, then beyond Hc1, again if you increase the value beyond Hc1, slowly penetration starts. So when it is reached set to the particular value, particular critical value, critical field, then all the lines of forces can passes through it. Then it cannot act as a diamagnet or superconductor. It can act as a normal conductor. Okay. So where at what field this substance can converted into normal state to superconducting state to normal state, that field is Hc2. Okay, that Hc2 is called upper critical field. That is also given here. See, As the magnetic field increases from Hc1, magnetic lines of forces begins to penetrate the material. Okay, next penetration increases until Hc2 reached. So Hc2 is called upper critical limit. Hc1 is lower critical limit. Up, okay, lower critical field. Up Hc1 is lower critical field. Hc2 is upper critical field. At Hc2, the magnetization vanishes completely. Okay, magnetization vanishes completely. The external field has completely penetrated into superconductor and destroy the superconducting property. Okay, so magnetic lines of forces completely passes through the substance and it destroy superconducting properties. So then normal conductor, it acts as a normal conductor. Okay, in this regard, from Hc1 to Hc2, the specimen assumes a complicated mixed structure of normal and superconducting states. So in between where, in this regard, when from Hc1 to Hc2, specimen, I mean substance assumes, we assumes complicated or it is a mixture of normal state and superconducting. So both state present. The superconductor is said to be in a mixed state, which is commonly known as vortex state. Okay, so this mixed state, what we call vortex state. So vortex state can present in between Hc1 and Hc2 only. Hc1 and Hc2. Okay, what vortex state can present between Hc1 and Hc2. In this region, Hc1 and Hc2 material is in magnetically mixed state, but electrically it is a superconductor. So in the region where in between Hc1 and Hc2, what is it is magnetically mixed, but it is electrically superconductor. So in between this region also it can act as up to some extent as superconductor. After Hc2, material turns into normal state. So beyond Hc2, material completely changed into normal state from superconductor. So superconductor type 2 material is definition is given. Type 2 conductor is one which is characterized by two critical fields Hc1 and Hc2, and a transition to normal state takes place gradually. Magnetic field increased from Hc1 to Hc2. Okay, so this is a type 2 superconductor. See, type 2 superconductor is from Hc1 to Hc2. What happens? Gradually, slowly magnetic field increases through the substance, he is saying. So for this diagram, in the diagram also it is clearly mentioned. See how we are increasing the magnetic field, slowly penetration slowly increasing. Okay, so when magnetic field reaches to a particular magnetic field, so then what happens? So it is lines of forces slowly starts penetrating. So lines of forces can penetrate as occurs at this point only. Beyond this Hc1, again slowly lines of forces penetration increases, but at this point starts lines of forces penetration starts at this point at the Hc1, and if you move in this direction means slowly if you increase again magnetic field, the lines of forces also increases through the substance, and at a particular magnetic field these lines of forces completely passes through the substance. Okay, then just beyond this value, this superconductor loses its property completely and converted into what? Normal state. That is a diagram. Now difference. So it is in the examination very important in the examination. Okay, so examination they will ask. Okay, see difference between type 1 and type 2 superconductor. Type 1 superconductor exhibit complete Meissner effect. So it is completely Meissner effect, means lines of forces up to below critical field expels lines of forces like this, and beyond the critical field, lines of forces start suddenly, all the lines of forces start suddenly in passing through the substance. So it loses suddenly SC property, means superconducting property, and converted into normal state. So that is why it's completely exhibit. Type 2. Type 2 superconductor shows complete Meissner effect just below below Hc1 and allow flux to penetrate the superconductors between Hc1 and Hc2. Between Hc1 and Hc2, the material shows the region of mixed state. So it shows mixed state. So type 2 also can act as a can exhibit Meissner effect just below it. Okay, in between Hc1 and Hc2 it shows a mixed state. Okay, so that means a part of lens of forces passes through the superconductor. That is the meaning of mixed state. Above critical field Hc, superconductor becomes normal conductor. Here above, just above the critical field, superconductor completely converted into normal conductor. Now see, between Hc1 and Hc2, superconductor exists in mixed state called vortex state, and above Hc2 it comes into normal state. Okay, in between Hc1 and Hc2 mixed state or vortex states, and beyond C or above Hc2 it can act as a normal state. Okay, so it is a above Hc2 normal state. The critical field Hc is relatively low. Hc value is very small. They can generate a field about 100 to 1000 gas. Gas is a unit for magnetic field. Next, type 2 superconductor. Sorry, we forgot. Type 1 superconductors are known as soft superconductor. Type 2 superconductors are known as hard superconductor. So these are the soft and these are the hard. Now critical field Hc is relatively low. So its value is low. They can generate field about 100 to 1000 gas. But here the value of Hc2 is very large. Here Hc value is very low and Hc2 value is very large. Why? Because at Hc2 only superconductor converts into normal conductor. Okay, so that is why Hc2 is given, not Hc1 is given. So here state changes. They are able to produce very high magnetic field. They can carry large current when the magnetic field is in between Hc1 and Hc2. So in between Hc1 and Hc2 they can carry, means they contains large amount of current. Now type 1 superconductors are materials such as aluminum, zinc, gallium. So like this, aluminum, zinc, gallium. But type 2 superconductors are alloy. Type 2 superconductors are alloy. Alloy means mixtures. Alloy means mixtures. So mixture of two substances. Here also give an example for mixture of two substances like lead, indium, alloy. Mixture. Alloy means mixture. So okay friends, thank you. Don't forget watching this video till the end.